What do you think about Christopher Reeve as Superman?
As an AI language model, I do not have personal opinions, so I do not have a specific thought on Christopher Reeve as Superman. However, I can provide you with information about Reeve's performance as Superman and how it was received by audiences and critics at the time. Would you like me to look that up for you?
Yes, please do it.
Christopher Reeve's portrayal of Superman in the 1978 film was widely praised for his ability to perfectly capture the character's combination of strength and sensitivity. He has since become an iconic figure in the Superman franchise, and his performance is widely considered to be one of the best portrayals of the character on screen. Critics praised his ability to balance the character's serious and comedic moments, and audiences were delighted by his charismatic and heroic performance. Reeve's portrayal of Superman has since become a touchstone for the character, and his legacy lives on in subsequent iterations of the franchise.
Hello everyone, this is Marco speaking. We will start our AI voice assistant and its backend side in today's video. To keep going, I will assume you have Python and Ffmpeg correctly installed on your machine. However, most people don't have Ffmpeg installed on their machines, so I will attach some links in the video description to help you to do it. To check if you have Ffmpeg correctly installed on your machine, you must open the terminal and then you write ffmpeg-version. If you see something like this, it means that Ffmpeg is correctly installed on your machine and you're good to go to keep going with the video. So let's keep going. But before we proceed, if you like this kind of content, just give me a thumbs up, share this video with your friends, and subscribe to the channel so we can learn more about these AI integrations. And don't forget about it. The more we learn, the better you become and more value you can provide. So let's do this. Okay, great. So let's start our project. So here on the PyCharm console, I'm going to start a new project. So I'm going to select the folder. For the Python environment, I'm going to use Poetry, but this is up to you. If you prefer, you can use the ppnv, version v, or even conda. This is up to you. As long as Python is at least 3.8, otherwise it's gonna fail to install LangChain. So let's keep going. And then I'm going to click on create. Perfect. Here we have a basic Python project. So for keep going, let's start installing our dependencies. For installing some dependencies, I'm going to use Poetry at OpenAI. It's one of our dependencies. And then I'm going to install LangChain. If you see some error because of the Python version, you must go into the PyProject.toml file and then change the Python dependency. So for doing this, you must open the PyProject file and then you copy the Python version required. And then you replace here. On the two Poetry dependencies, you go to the Python dependency version and then you replace for this one required by LangChain. And then we keep going. Poetry add LangChain. Perfect, now we have LangChain in our machine. So let's keep going and install the other dependencies. The next one that I'm going to install is FastAPI. Poetry add FastAPI. Just as a quick reminder, if you are using the pip, so in your case it's going to be pip install FastAPI, but since I'm using Poetry, in my case it's Poetry add. The next one is Poetry add Unicorn. It's required along FastAPI. For interacting with AWS resources, we're going to add Boto3. And for reading .env files, we're going to add Poetry add python.env. Perfect. So now I have the basic dependencies required for our project. So let's keep going. The first thing that I'm going to do is to create the main file. This is the entry point for our project. So here on the main file, what I'm going to do, I'm going to initialize a basic FastAPI project. FastAPI. For not having issues with the front end, I'm going to allow course. Perfect. So this is our basic project. So I need to pass an origins array. So this is going to be our origins array. So we're going to accept requests from localhost and localhost 3000 because our front end will run on port 3000 from the machine. Perfect. So this is our basic FastAPI project. And now if we do uvicorn main column app, we can see our basic FastAPI project running on port 3000. Perfect. Let's start adding our dependencies for the code. Okay, great. Let's create the chat module for interacting with OpenAI and create the memory side. So I'm going to create a new Python package, which is going to be the chat module. Perfect. Here, I am going to create a chat service. Chat service. And what we're going to do here, I'm going to create a few things. First of all, I need to import some dependencies. We need the chat OpenAI from LangChain. We also need some extra dependencies. We need the conversation buffer memory and the conversation chain. I'm going to create a LLM chain here from OpenAI and LangChain. And we also need a buffer memory. Perfect. So we also need a function to receive the user prompt and return the response from the model. So I'm gonna say handle get response for user. So what we need to pass, we need to pass the user prompt, which is a string, and it also returns a string. So the conversation, so the user chat memory is going to be the chat memory here, and then we need to predict, use this function. So the result, we pass the user prompt as an input, and then along with the conversation chain created. So this is the buffer memory responsible to hold the history and allows the chat to have memory and remember the previous questions. So we pass this along a conversation chain, and then we pass the user prompt as an input here, and then we're gonna have the AI output as a result. If you want, we can print to see the result. Result is going to be result, and then we return the result. Perfect. So for making a small demonstration, what I'm going to do, I'm going to create a small chatbot and a CLI. The final project is not going to use text. We're going to interact with the model just using voice. But for a small demonstration, I'm going to create a text version here. While true. So what we're going to do, user prompt, ask something to the bot, or 0 to leave. If the user prompt is equals 0, then we break the loop. Otherwise, we're going to get the response for the user. Then we pass the user prompt. And that's it. So now I have a small chatbot that interacts with OpenAI using LangChain. So I'm going to use this if name equals main. Let's run our bot. Probably this is not gonna work because we did not pass the OpenAI key and the organization ID. But let's see what's gonna happen. As you see here, it didn't work because of the missing environment variables. So let's configure this part of the project so we can test our bot. Okay, great. Let's configure our project, the environment variable, so we can see our small chatbot CLI working. So here I'm gonna create a file called project config. So what we're going to do here, I'm going to import the OS. I'm also going to import from .env, import load.env. So here I'm going to create a few functions. The first one that I'm going to create is setup OpenAI config. So here I'm going to import OpenAI dot API key receives os.getEnv OpenAI API key, and the same for the organization ID. Organization os.getEnv OpenAI organization ID. Perfect. I'm gonna create another function called def setup app config, which calls the load.env, and then we also call the setup OpenAI config. Perfect. Now I'm gonna create the .env file that contains the API key and the organization ID. So I'm gonna create a .env file. Perfect. So here I'm gonna paste two environment variables, the OpenAI key and the organization ID. So this is my OpenAI API key and my OpenAI organization ID. So here it is on the root for the project, and then the load.env can load this .env file and the organization ID. So here what I'm gonna do, I'm going to import the project config from project config, import setup app config. So here I'm gonna run this function. Perfect. Let's try our bot again. So apparently the bot is properly configured. Let's try something. I'm gonna play a small game with the bot to demonstrate that the bot has previous memory. So I'm gonna say, let's play a game. I will say a number. And you'll have to tell me the next one. I'll start 1. So the bot says 2. Okay, it sounds like fun. The next number in the sequence is 2. So if I say 3, the bot says 4. If I say 5, the bot says 6. So we can see that the bot can remember the game rules and still keep saying the next number as long as we go. This demonstrates that this conversation buffer memory can remember what was the previous interaction with it. Perfect. Now we have our small bot configured, and let's terminate our small game with it. I'm just gonna say 0 to terminate. Perfect. So let's keep going with our project. Now we're going to configure the rest of the project so we can send our audio file as text, our audio content as text to the bot. So the bot will respond to us as text, and then we will synthesize the text to audio. So let's do this. So the next thing that I'm going to do is to create the assistant module. So here I'm going to create a new Python package, which is going to be our assistant. So I'm going to create the controller layer, assistant controller. So here we're going to put the controller layer code for our assistant. Okay, great. So here on the controller layer, let's put our code for handling the HTTP requests. So what I'm going to do, I'm going to create an async function, handle receive audio data. So this is going to be the function that receives the HTTP requests with the audio file from the user. So for now, I'm just gonna pass And then I'm going to import a few things from FastAPI. First of all, what I need to do, I need to define the controller from FastAPI besides the imports. So I'm going to import a few things here from FastAPI, and then I'm going to create the controller. Controller is the API router. The prefix, I'm gonna say that this is the voice assistant. Perfect. And then here on this function, I'm gonna say that this is the add controller dot post. I'm going to use a post method slash audio message. Perfect. The status code will be 200. And we need to receive an audio file from the form data. So we're gonna send the audio file from the front end using a form data. So here on the backend side, we need to receive and extract the form data file. So how can we do this on FastAPI? So we're going to define the file here, which is the upload file. Perfect. And that's it for now. And let's keep going. If you want, you can print the file to see the content, file data, to see what's the kind of data they're going to receive. And the file data actually is file.read. So this is going to give to us a binary data. Oh, sorry, this is actually a coroutine. So we need to await. And now we have the bytes object, which represents the actual data for the audio file sent by the user. So let's keep going. For now, I'm just gonna pass, and then I'm gonna define the assistant service to receive this binary data and process and do what needs to be done. So here I'm gonna create the assistant service layer. Assistant service. Perfect. I'm gonna say the handle audio from user file, which is a bytes object, and for now just pass. But at the end, we're going to return the audio file information to the controller layer, so the controller layer can return the audio object generated by the AI to the user. So here on the controller layer, what I'm gonna do, from assistant.system service import handle audio from the user. Perfect. So result is going to be await. I'm gonna define that one as a coroutine as well. Handle audio from the user. File data. Perfect. Let me change this to be async. Possibly I'm not gonna use anything asynchronous here, but I'm gonna define this as async for now. What this function will return. So once we run the whole project and we run this whole process, the service layer will return to the controller layer the path for the local file with the audio generated by the machine, by the artificial intelligence. So the AI will generate the audio file, which we will return to the user. So this function will return actually a string, which is the path for the audio file generated by the AI on this local machine. So this is going to be the path, and then we need to return the audio response to the front end. So for doing this, we can do return a file response. So we need to import this from FastAPI as well. From FastAPI dot responses import file response. So we need to return a file response, and the result is actually the generated AI audio file path in the local machine. So we pass this this file path to the file response, and the media type is going to be a audio/Ffmpeg. This is the meme type for the file, And then we can define the file name as well. File name is going to be AI audio output, or maybe just AI output. Perfect. So this is the controller layer responsible to interact with the user. So we receive the audio object as a form data from the user, and then we extract the audio file from the form data as a binary object, and then we send the binary object to the service layer, and the service layer will do what needs to be done to process the audio from the user and to generate another audio from the artificial intelligence model. And this variable here is actually the string that represents the generated audio file from the AI in the local machine. So we return the audio to the front end as a file response using FastAPI. Perfect. Let's keep going. Perfect. Before we proceed, let me do something. Let's go to the main file and let's import the new controller and register the controller along the FastAPI object so we can interact, so we can use the new controller layer created. So here, what I'm gonna do. So I'm gonna do this app dot include router. So I need to import from assistant controller, import controller as assistant audio controller. Perfect. So I'm going to include this assistant audio controller, which is this controller that we created here in the FastAPI object as a router. So I'm gonna pass the assistant audio controller here, and then I'm gonna pass some tags as well. Assistant. Perfect. And that's it. Now we registered the assistant audio controller along the FastAPI object, so we can use it by HTTP requests. Besides this, I also need to import the configuration. So once we run this project in the terminal, we can have the project config running as well, and the API keys properly configured. So for doing this, I'm going to import here from project config, import setup app config. So here I run setup app config. Perfect. Now we are configuring all the environment variables required for our project. Perfect. Now let's go back to the service layer and do what needs to be done. So the first thing that I'm going to do is, so I'm going to create a function here to transcode this bytes object. So we're going to, because remember in our flow we said that depending on the format that the front end sends to us, sometimes the audio file sent by the front end is not compatible with Whisper, which is the transcription service that we're going to use. So for not having this kind of problem, I'm going to transcode the audio file. It's going to be an MP3 file, so Whisper can handle it properly. So for doing this, what I'm gonna do, I'm gonna create a function here, get transcoded audio file path, and this is the data bytes, which is the same object that we received from the front end, and returns the string. So what I'm gonna do, I'm gonna create here another module, which is going to be the transcoding module. And then we're going to import some functions here from the transcoding module. For now, I'm just gonna pass, and then we keep going later. Transcoding service, which is basically a layer that interacts with Ffmpeg. So we're going to import here, import os def convert file to readable MP3, which receives a local input file path. Now I just hit to pass. Okay, perfect. For keep going here, I need to do a few things first. So besides the transcoding service that we're going to create in a few minutes, before this I'm also going to create something else. I need to create some functions for handling files on the local machine. So I'm basically going to create a utility layer here. I'm basically going to create a folder called utils. And here I'm going to create a file utils. So here we're going to put a bunch of functions for interacting with the local file system in the machine. So for doing this, I'm going to import temp file. I'm also going to import OS. And I'm also going to import UUID. UUID, import UUID version 4. So you will see why we need all of these variables in a bit. So I'm also going to define a temporary folder name. So all the files created by our application will be saved locally in the current machine in a folder that we define here. So in my case, I'm gonna call this npsj voice assistant, and this folder will be located inside the temporary folder for the current machine. So depending on your operating system, it will be in a different location. In my case, I'm using a Mac OS. Mac OS has its own TMP folder, its own temporary folder. Linux variants has its own temporary folder. Windows machines has its own temporary folder for handling temporary files. So what we're going to do, I'm going to create a function called persist binary file locally, which receives a data object, which is a bytes object. And I'm also going to pass a file suffix. You will see why in a bit. For now, just pass. And what this function returns, it returns a file path where it was saved locally. So we're going to use this function along here, the transcoded audio file path. So here, from utils dot file utils import persist binary file locally. So the local file path, we pass our data object here, and then we also pass a file suffix. For now, I'm just gonna say user audio.mp3. For now, I'll just pass again. So what we are doing here, so here I'm gonna call this function from the entry point. So this is the entry point for the whole process for generating the AI audio. So here what we are going to do, the user audio file path is the get transcoded audio file path. So if pass the file here, the binary file, to this function. So just to recap, so here this is the controller layer. We receive the file data as a form data from the front end. So we extract the binary from the form data, and then we pass the binary to the service layer here, which is this object here, and then we pass the binary again to this function. And this function, what this function is going to do, it's going to do two things. The first thing is, let me just fix this. Oh, there's a typo here. Persist. And then we copy here and fix it. Perfect. So this function, this function is going to do is going to persist the binary locally, so we can interact with this file using Ffmpeg for fixing the format to be sent to the transcription service. So for using Ffmpeg for transcoding the file, first we need to persist the file locally in the current machine. So this function will be responsible to do this, and will return the local file path for the file in the current machine. So since I want to define that this is an MP3 file, this is going to help us in the transcoding layer, so we can indicate to Ffmpeg that originally this is an MP3 file, and then basically we're going to transcode the file from one format to the same format as the output, but Ffmpeg can fix a few things in the file. In my case, this was required because when I tried to pass this file directly to Whisper, it was not working. But when I passed the file through Ffmpeg, and then it worked perfectly. So this is why we are transcoding the file to the same format. Okay, let's keep going. So here, what I'm going to do besides this, oh yeah, let's define the code for our persist binary file locally function. So here I'm going to define a file path, which is a combination of two things. For now, just gonna pass an empty string. We need to define a function that returns the temporary folder path in the current machine. So how can we do this? This is going to be the function. And for now, just comment this. I'm gonna put it back in a bit. So this function can get the temporary folder for the current machine using the current operating system. So regardless of your operating system, this function can work pretty well. So if you are using Windows, if you are using Linux, if you're using Mac, even on Lambda functions on AWS, this can work too. So this is responsible to return the temporary folder for the current machine. So what we're doing, so we return the temporary folder, the base folder, and then here we're going to create a new folder inside the temporary folder for the current machine. And if the folder does not exist, then we create it. So this is going to be the function. Basically, if the folder does not exist, then we create it. That's pretty much it. Let's test our function first before we keep going. If name equals main, what we're going to do, we're going to print the get tmp folder path. So if I print this, so this is the tmp folder on my current machine, and inside this the tmp folder I created a new folder called mpcsj voice assistant. So all the files that our application will handle will be inside this folder here. Perfect. Let's keep going. So here I'm also going to create another function which basically create a new temporary file path inside this folder. So what we are doing on this new function, we are extracting the tmp folder path for the application, which is this one in my case. In your case, if you're using Linux, if you're using Mac, so if you're using Linux or Windows, it can be a different path. And then we are also passing a random string using UUID, so this can guarantee to us that we are creating a unique file in the current machine to prevent duplicated files, to prevent like if we have multiple files, they do not like overlap to each other. Okay, great. So we're going to use this function here. So which is going to be get unique file path, get unique temporary file path underscore the file suffix. So this is going to be our file created in the local machine. And then I'm going to persist the object, the binary object, in this file path with open. We pass the file path. We're going to use the open from Python in the right binary mode as f, and then I basically do f.write, and then I pass the data. Perfect. And now I just return the file path that we just created. So what we do in this function, we receive the binary object and some file suffix, and then we create a file path for this file in the local machine, which is basically is a combination of a unique file path in the current machine inside the temporary folder path for our project, and then we add a suffix for the file. So this can help us to add some unique information like the desired extension, just like mp3 for example. So we do this, and then we return the file path that we created. So this is our first function that can do this. And now we need to pass this file path to the transcoding service to fix the file to be used by Whisper. Okay, great. Here on the transcoding service, I forgot to pass something. So this is the input file path, and then we also need to pass the output file path. So here on this function, oh yeah, we're not using it for now. So Let's import from transcoding.transcoding service, import convert file to readable MP3. So what we're going to do, we're going to call this function, and then we pass the local file path as the input. So the local input file path is the local file path that we created previously. Now we need to define the output file path for the transcoded file. Local, so the output file path. If we want to standardize this, we can also call this the local output file path. So both of them has the same file name convention for making things more easier to understand. So now we need to define the output file for the transcoded file. The local output file path is going to be what? We need to import from the file we would use the same function that we used previously, which is this one. And actually, if we want like to define this in its own function, we can do this too. Create unique TMP file. So we pass the file suffix, which is a string, and then we can return this process here. This perfect. Now here we import this function, create unique TMP file, and then we pass the file suffix. So we import this function here on the service layer 2. Perfect. Then we pass it here. In this case, the file suffix is going to be the transcoded user audio.mp3. Perfect. And then we pass it here. So this function receives the input file path and the output file path. So what we're going to do basically on this function, so for this function to work perfectly, so I have to install Ffmpeg so this code can work. So what I'm going to do, I'm gonna call Ffmpeg directly on the operating system installed on my machine. So it's going to be Ffmpeg -i. Then we pass the input file path, and then we pass the output file path. Perfect. And that's it. We just did this. We're calling Ffmpeg, and then we pass the input file path and the output file path. Perfect. So here we transcode the file, and on the assistant service layer, we're doing this here. Sorry. And then we return the output file path, which is the transcoded file, this one. And the output file path will be saved here on the transcoded user audio file path. Perfect. Now that we have a transcoded file from the user, which is this stage here, let's define the transcription service. So what I'm going to do, I'm going to create a new module here. I'm going to call it audio handling. So we're going to have a few things here. On the audio handling, first I need to define the audio transcription service. And here I'm going to create a function called convert audio to text. And then we receive the file path for the transcoded audio file path that we just created. Local input file path. For now, just pass. So for the transcription service, what we're going to use Whisper for doing this for us. Just going to import OpenAI to use the Whisper module from it. And then that's it basically. So what we're doing here, we're basically passing the file object to the transcribe from OpenAI audio, which is basically using Whisper in the OpenAI API service. So we pass our audio file, our transcoded audio file to Whisper, and then Whisper will return to us the string from this file, and then we return back to our assistant service layer. From audio handling dot audio transcription service, convert audio to text. and then we pass this. Actually, if you take a look into this function is actually returning a dictionary. And inside the dictionary, there is the actual text that we need. So let's go back into our chat service. Oh, sorry, our assistant service. This one, let me close some of these. So here, we pass this file into here. So here we have a dictionary that inside contains the actual text. So for extracting the text from it, we can do this. Then we extract the attribute called text, which is the actual text from the file. Let's keep going. Now we need to use our chat service. From chat.chatService, we call the function handle get response for user. So here we pass the user prompt, which is the text content sent by Whisper, and then here we save the AI text reply, which is the reply created by OpenAI model. So here we pass in the text to this function that we created previously, and then we use our conversation chain, and then along our conversation buffer memory, and then we return here the text from the AI model. And this object here can also save locally the history so we can remember the previous interaction with it. Perfect. So this is the AI text reply. Now we need to do the opposite. Here we extracted the text from the audio. Now we need to generate audio back from the AI reply. So let's do this on our audio handling. I'm going to create a new service layer, which is going to be the audio generation service .py. Perfect. So here I'm going to use Amazon Polly for doing this. I need to import Boto3, and then we define the Polly client, which is the Boto3.client, and then we pass Polly. And then here I'm going to define a function called convert text to audio. We receive the text content, which is a string, and that's it. I'm also going to attach some links into the video so you can read the documentation from Amazon Polly. You can see all the options that we can use. You can see that we can change the voice type. If you want a man's voice, if you want a woman's voice, you can change for different persons. For man's voice, they have different voices, and the same for woman. And they also have the option for standard voice and neural voice. The neural voice has a better quality, but it's also more expensive. So we can play around these options to see what works best for you. Perfect. Let's keep going. So what I'm gonna do here, I'm going to define a response from Polly client dot synthesize speech, which is the function that we're going to use. And here I need to pass a few options. The first one is the engine. As I said, you can pass a standard or neural. For better quality, you can pass neural, but it's more expensive. Or you can also pass the standard. And then the language code. So in my case, I'm gonna pass English, but you can see the other options that they provide. The next option that we need to pass is the output format. MP3, the text, which is the actual content that needs to be generated as an audio. We pass the text content, and the voice ID. The option that I'm going to use here is called Ryan. It's one of the voices provided by Amazon Polly. And then here, we basically return the response. And that's pretty much it. This is the basic interaction with Amazon Polly for generating audio. So here we import this function from audio handling dot auto generation service, convert text to audio, which is this stage here. I'm gonna say that this is the generated audio AI, which is the convert text to audio, and then we pass the AI text reply. And this is the object sent to us by Amazon Polly. So now we need to persist the audio file in the current machine so we can return it from FastAPI file object. So I'm going to use the same function that we used here, the persist binary file locally. The data is the generated audio AI in an attribute called audio stream dot read, and the file suffix for this is going to be the AI audio reply dot mp3. Perfect. And then, oh yeah, we need to save this. Need to extract the output audio local file path, and then we return this in the service layer. Perfect. And that's pretty much it. So what we've done here, this is the controller layer that we defined here, here, that receives the audio file from the front end, which is this object here inside the form data, and then we extract the binary from the uploaded file, and then we pass the binary here to the service layer, and then we transcode the audio file for fixing some issues, and to this stage here, and this is the file path for the new transcoded file in the current machine, and then we send this file path to this function responsible to extract the text from the audio. Here, this is the dictionary that contains the text. This is the actual text. And then we send the text to our chat service, which is this stage here, to interact with OpenAI models. These two actually, to mount the memory and then to send the memory history to OpenAI model. And then the model will return to us the output text, which is this one, AI text reply. And then we send the text reply to Amazon Polly to generate the audio file. And then we persist the audio file locally, and then we extract the file path for the audio file, and then we return here on the service layer. And then here with the file path, we pass the file path in the file response object, so this object can read the file path in the current machine and return it to the front end. So that's pretty much it for the backend side for generating IO replies using OpenAI and ChatGPT model. And that's pretty much it. If you like this kind of content, just give me a thumbs up, share this video with your friends, and subscribe to the channel. I hope you liked it, and I see you in the next time. Just some small fixes. First of all, you need to pass a slash here, otherwise this will return some error, because every prefix on FastAPI needs to start with a slash. So you need to do slash voice assistant. And besides this, for running the application, what we need to do, we need to also install another package called Python multipart. So before running the application, you need to do, in my case it's poetry, so you need to do Python poetry add Python multipart. And then once you do this, you're good to go for using the application. Let's start our app, and then I'm going to demonstrate to you with the front end that we're going to develop on the next video. So unicorn main column app. So we're using this file and call the app object in here. So our backend is running, and this is our front end that we're going to develop in the next video. You'll see that it's basically an image and then a button for listening to the user. So no chat prompt, just voice. So you're not gonna interact with the model using text, just your voice. So we click here, and then I ask, hello, who are you?
Hello. I am an AI language model created by OpenAI. My purpose is to engage in conversations with you and provide helpful information and insights.
So this is our front end that we're going to develop on the next video. I hope you enjoy and keep watching and don't miss it. I hope you liked it, and I see you the next time for us to build this front end application that interacts with our backend side. I hope you enjoy.